Okay, here is the next problem. In this problem we need to show that the sequence Sn is convergent. In order to show that the sequence is convergent, first we need to see whether the sequence is an increasing sequence or it is a decreasing sequence. If the sequence is an increasing sequence, there exists an upper bound, that is the sequence will be bounded above. If it is a decreasing sequence, then there exists a lower bound, that is bounded below. So, we will start with the problem. He has given the sequence, he has defined the sequence as Sn is equals to 1 plus 1 by 3 plus 1 by 3 square, so on up to 1 by 3 power n, for all n values are positive values. Now, in order to show it is convergent, we will take another term, or we can say another sequence from the same sequence Sn. We will derive another sequence as Sn plus 1. That means we will get all the n values. After n values, what will be the next value? That is n plus 1 value, right? So, that is nothing but Sn plus 1. So, we will write the values as Sn plus 1, which is equals to 1 plus 1 by 3, 1 by 3 square, so on up to 1 by 3 power n. Till here these all are n values which he has given in the question. After nth term, what will be the next term? That will be n plus 1th term, right? So, it will be right 1 by 3 power n minus 1 plus 1. This is n minus 1 we consider as nth term, right? So, here it will be n minus 1 plus 1. So, here n plus 1, which is equals to 1 plus 1 by 3, 1 by 3 square, so on up to 1 by 3 power n. Here plus 1 and minus 1 get cancelled, we will be remaining with only 3 power nth term. Next, we need to consider, we need to take the difference of the two sequence, or we can say two terms of sequence, that is Sn plus 1 minus Sn, which is equals to, what is Sn plus 1 terms? All these terms which we have defined now, that is 1 plus 1 by 3 plus 1 by 3 square, so on up to 1 by 3 power n minus 1 plus 1 by 3 power n. Next, minus, here in between we will be getting the negative sign. What is Sn term? That is given in the question, right? So, that is 1. Since we have minus in between, all the terms after minus will be negative, right? So, it will be 1 minus 1 by 3 minus 1 by 3 square, so on up to minus 1 by 3 power n. In this term, we have one positive term as well as one negative term. So, one positive term and one negative term get cancelled, that is plus 1 and minus 1 get cancelled, plus 1 by 3 minus 1 by 3 get cancelled, plus 1 by 3 square and minus 1 by 3 square get cancelled. All the terms will get cancelled because we will be having one positive term and one negative term. We will be just remaining with 1 by 3 power n term. We will write it here. Next step, that is Sn plus 1 minus Sn, which is equals to 1 by 3 power n, for all n values are positive values. In the next step, we are writing it as Sn plus 1 minus Sn term is greater than or equals to 0. Why we are taking greater than or equals to 0? Because we have got only one term, that is 1 by 3 power nth term. If you substitute n is equals to 1, that is you will take 1 by 3 power n. If you substitute n is equals to 1 in this, you will be. So, we have got Sn plus 1 minus Sn term as 1 by 3 power n, right? We are saying this 1 by 3 power n is greater than or equals to 0. So, we will take this 1 by 3 power n. If you substitute n value in this, you will get 1 by 3. This value is greater than 0. So, we are taking, if you substitute 2 also, n is equals to 2, you will get 1 by 3 square, that is you will get 1 by 9. This is also greater than 0. So, we are writing Sn plus 1 minus Sn term is greater than or equals to 0, with for all n values are positive values. Again, in the next step, what are we doing? We are taking this minus Sn to the right hand side, that is Sn plus 1 is greater than Sn, which is nothing but Sn is less than the next term, that is here as the sequence is going on, the terms are going on increasing. So, we say that the given sequence is an increasing sequence, as Sn is the previous term and Sn plus 1 is the next term, right? So, as we go on increasing, the terms are increasing. So, we say the sequence is an increasing sequence. We have got the sequence as an increasing sequence, right? So, now we need to prove whether this sequence has a bound or not. So, for that we will take the given sequence as this is the given sequence, right? We say this sequence is in the geometric progression type, because in the geometric progression types, in the geometric progression we will have the next element as here we have 1 plus 1 by 3. After 1 by 3, all the elements are getting multiplied with the previous term. So, that is nothing but geometric progression, right? From that we will take the last Sn term. This is the formula of geometric progression, nth term formula, that is S suffix n which is equals to a into 1 minus r power n by 1 minus r. Here a is nothing but the first value of the series. Here the first value is 1. So a value will be 1 and r is nothing but the common ratio. You can say the common ratio or you can say the difference. So it will be 1 by 3. Here a value is 1 and r value is 1 by 3. Substitute this here. So here it will be 1 into 1 minus 1 by 3 power n by 1 minus 1 by 3. So it will be like, if you multiply anything with 1 you will get the same value, right. So 1 minus 1 by 3 power n. If you take this 3 to the numerator, you will get, here it is dividing, it will be multiplying in the numerator, right. So the next step will be 3 into 1 minus 3 power n. 1 by 3 power n. You will be getting, if you multiply this 3 inside the brackets, that will be 3 minus 1 by 3 power n minus 1. That is, we can say the sequence Sn. Here the 3 is decreasing, right, because some number is here we are subtracting something with 3. So here the 3 will decrease. So we are saying that the given sequence is values are less than 3. So here the sequence Sn is increasing as well as bounded. As the sequence is increasing, we can say there exists an upper bound, that is nothing but the sequence is bounded above. Therefore it is increasing and bounded. We say that the sequence is convergent sequence, right. Next problem. So problem number 2, here he has given two values, that is he has given the first value S1 as root 2 and he has given the n plus 1 term, that is n plus 1 is equals to under root of 2 plus Sn. Here also we need to show that the sequence is convergent. Here also same, we need to show whether the sequence is either increasing sequence or decreasing sequence. If it is increasing, we need to show it is bounded above. If it is decreasing, we need to show it is bounded below. So we will prove this theorem by using the mathematical induction formula, right. What is the mathematical induction form? That is, if we need to prove something, there will be 3 steps. We need to prove it for n is equals to 1. The condition is true for n is equals to 1. This is the first one. And what will be the second step? We need to just assume it for n is equals to k. We need to just assume that particular condition is true for n is equals to k. But in the third case, we need to again prove it for n is equals to k plus 1. In the first step, we need to prove. In the second step, we just need to assume that the condition is true. In the third step, again we need to prove. This is nothing but mathematical form. If we prove this 3 condition, we can say that the condition is true. Here we need to first see whether the sequence is increasing sequence or else decreasing sequence. So we will start our procedure. That is, first write the given condition. He has given the first term S1 as root 2 and he has given the Sn plus 1 term as root 2 plus Sn. Now what we have first term. In order to see whether the sequence is increasing sequence or a decreasing sequence, we need the exact value of the second term also, right. So we'll get that term by substituting n value in this Sn plus 1 term, right. If we substitute n is equals to 1 in Sn plus 1, we'll get the value, that is, if n is equals to 1, we'll get S1 plus 1, because here we have Sn plus 1, right. In the place of n, you need to substitute the n value. So you will be getting S1 plus 1, that is S2, which is equals to under root of 2 plus S1. Why we are writing 1 here? Because in the place of n, we are substituting 1. So under root of 2 plus S1 here. We have already got the value of S1 he has given in the question. What is the S1 value we have? He has given S1 value as root 2. We need to substitute it here. That is, which is under root of 2 plus root 2. Again, what is the root 2 value? Root 2 value is nothing but 1.414. 2 plus 1.414, it will become 3.414. If you do the square root for this value, you will be getting 1.84. So we have got exact 2 values. First value is S1 is root 2 and what is the root 2 value? 1.414, right. And what is S2? Second term of the sequence, that is 1.814. If you compare this two, what you are saying that the value of S1 is less than the value of S2. That means S2 value is increasing. So here it is clear that as we goes on, the terms are increasing. Like if you find the S3 value will always be greater than S2 only. So here the sequence is increasing sequence. We need to show this. Okay, what we need to show that S1, this term is increasing, that is S1 is greater than S2. What is the actual sequence we need to show? Sn, right? Sn is greater than Sn is less than Sn plus 1. This is the actual term what we need to show for increasing sequence, right? We will show this with the help of mathematical induction form, right? We will use this to show this. So now we have known that the sequence is an increasing sequence. So now we need to show this, that is Sn is less than Sn plus 1. So if you substitute one value here, like if n is equals to 1, we have already seen if n is equals to 1, it is true for n is equals to 1 because S1 value is 1.414 and S2 value is 1.84, that is S1 is less than S2. Therefore this condition is true, right? So next step of the mathematical induction is we just need to assume it for n is equals to k. We just need to consider it, right? So substitute the k value here in this condition, you will be getting sk is less than sk plus 1. We just need to consider. Again in the third part, we need to show it for n is equals to k plus 1. This is how we will show. See, for this we'll need to take the assume part what we have taken. And what are we doing in the next step? We are adding 2 on the both side of this inequality, that is 2 plus sk is less than 2 plus sk plus 1. After that we are adding square root on the both sides of the inequality, that is root of 2 plus sk is less than root of 2 plus sk plus 1. Now he has given in the question, what he has given, the value of n plus 1 term as 2 plus Sn. Here it is n, but here it is k. So what will be the value of this? That is nothing but sk plus 1, and this is, here it is k, so we have written k plus 1. Here it is k plus 1, that means you will be getting sk plus 1 plus 1, that means you will be getting sk plus 2 value, right? So this is the value. Here we have got, if we substitute n is equals to k plus 1, we have got sk plus 1 is less than sk plus 2. That is nothing but the first value is less than the next value, right? So the sequence is increasing sequence. Hence by the mathematical induction we say that the sequence is an increasing sequence. That is nothing but the first term is less than the all next terms. Next, if we have got the sequence is an increasing sequence, we need to show it is a bounded above sequence, or we need to show there exists an upper bound, right? Again for this showing the boundedness property, again we will be using the mathematical induction form only, okay? As again see, given what he has given first term, what is the first term he has given? S1, which is equals to root 2 he has given, right? So what is the root 2 value? That is 1.14, right? Root 2 value is 1.414, right? So this value is nothing but 1 only, approximate value is 1. So what are we saying? S1 value is less than 2. Can we say, because S1 value is root 2, right? Root 2 value is 1.414, that is nothing but approximate value is 1. So here we are taking S1 value is less than 2. So here we need to show Sn value is less than 2 in order to prove the boundedness property. So here according to the mathematical induction, it is true for n is equals to 1, that is S1 value is less than 2. Now second, what is the second condition? That is we need to assume it for n is equals to k. So we just need to write it, assume it for s suffix k is less than 2. Next, again in the third part what we need to do? We need to prove it for n is equals to k plus 1, right? Again similar procedure what we have done here, adding 2 on both sides and squaring. We will do it here same. That is again add 2 on the both sides of the equation. You will be getting 2 plus sk is less than 2 plus 2. Again in the next step same, squaring on both sides. That is we will be getting under root of 2 plus sk is less than root 4. What is the value for root 4? That is 2. That is nothing but 2 plus sk is less than 2. Again according to the question, what is 2 plus sk value? That is nothing but sk plus 1. Therefore sk plus 1 is less than 2. Therefore by the mathematical induction 3 steps we can say that we have Sn value less than 2. Therefore this sequence Sn is bounded above as well as increasing. If the sequence is increasing as well as bounded above, then we say that the sequence is convergent sequence.